As the salt touches the surface, the area around it begins to dimple and liquefy in time lapse. Dark, moody orchestral strings swell. Hush ice. Hush hush the hook. The lie you live by. It's one of those bedrock facts of childhood, isn't it? You learned it when you were 8 years old. Right around the same time you learned that the sun rises in the east and that you shouldn't eat the yellow snow. You've seen it with your own eyes 1,000 times. You sprinkle the white crystals on your frozen driveway, and like magic, the solid ground turns to slush. A visual, a split screen. On the left, a child sprinkling salt on a sidewalk. On the right, a close-up of an old-fashioned ice cream crank. You toss salt into a bucket to make ice cream, and the temperature drops so low it freezes the cream solid. It's obvious, it's intuitive, and it is completely fundamentally wrong. Which as the screen goes black, large, minimalist text appears. S. Salt does not melt ice. Experience the sky. If the laws of I love a good wrong answer. Not because I enjoy catching people out. No, I love a wrong answer because it usually means the real answer is far more interesting than anyone expected. And this one is a beauty. What actually happens when salt touches ice is stranger, more subtle, and more revealing about how the universe really operates than any melting story could ever be. Once you see it, you'll never look at a glass of ice water the same way again. The physics core, the invisible war. To understand why the melting story is a lie, we have to ask a question that sounds too simple to be useful. What was the ice doing before the salt arrived? Visual, a minimalist animation of an ice cube. We zoom in, past the surface, past the molecules, until we see individual water molecules, arranged in a rigid, hexagonal lattice. Sitting there, static, frozen, inert. Nature says no. Time at the boundary where ice meets the air, or a thin film of water, there is a frantic, invisible war going on. Scientists call this dynamic equilibrium. Imagine a crowded nightclub with a strict one-in, one-out policy. At any given second, 10 people are pushed out the door into the cold street because the dance floor is too cramped. But at that exact same second, 10 people from the line outside are ushered in. If you're standing across the street, the club looks full. Nothing seems to be changing, but inside, it's chaos. It's chaos. We see blue molecules vibrating and breaking away from the crystal, melting, while white molecules from the surrounding liquid slow down and click into the lattice, freezing. On the surface of every ice cube, the demolition crew. Molecules are shaking loose, breaking their bonds, and becoming liquid. That's melting. 2 the construction crew. Liquid molecules are slowing down, locking into the pattern and becoming solid. That's freezing. At these 2 rates are exactly equal. For every molecule that escapes the crystal, another one joins. It's a perfect tie. A stalemate. The ice doesn't stay frozen because it's solid. It stays frozen because it's solid. It stays frozen because it's rebuilding itself as fast as it falls apart. The great sabotage, the micro versus macro, the great sabotage of giant stylized sodium ion and chloride ion drop into the liquid film on the ice surface like heavy boulders. When you sprinkle salt, it doesn't attack the ice. It doesn't have tiny hands to pull the crystal apart. In fact, the salt doesn't even touch the solid ice. It dissolves into that tiny microscopic layer of liquid water that lives on the surface of all ice, a phenomenon called pre-melting, first guessed by Michael Faraday. Here is the aha moment. The salt does absolutely nothing to the melting rate. The ice crystal underneath has no idea the salt is there. The molecules in the lattice keep shaking loose at the same speed they always did. The demolition crew is still working at 100% capacity. But the freezing, the salt cheats. But visual analogous animation. The construction crew, water molecules are trying to reach the ice surface to lock in, but they keep bouncing off the big bulky salt ions. Think of it like our nightclub analogy. The one-out rule is still happening. People are leaving the club at the same rate. But now someone has piled a bunch of heavy furniture, the salt ions, right in front of the entrance. The people outside are trying to get in, but they're bumping into chairs, tripping over tables, and getting knocked off course Fewer people make it through the door. Asterisks the result. Dissipaxing. Melting rate, 100%. Tide per cease melting rate, 100%. Tide per cease freezing rate, 50%. The balance is broken. More molecules are leaving the crystal than returning to it. The ice shrinks. The puddle grows. Asterisk salt doesn't melt ice. Salt sabotages, freezing. As times hash the counter-argument, why thermodynamics wins. But wait, you might say, if I put enough salt on, can I melt ice at any temperature? Asterisk Western, not a single galaxy. If your theory is salt melts ice, you can't explain why salt stops working at that temperature, the ice wins. Why? Because as it gets colder, the demolition crew slows down. The molecules have less thermal energy. They don't shake as hard. Eventually, even with all those salt furniture, obstacles in the way, the freezing rate, the construction crew, catches up to the sluggish melting rate. Visual. A graph showing the freezing point dropping as salt concentration increases, bottoming out at the eutectic point. A new truce. Nature always finds a balance. It just moves the goalposts. This is asterisk Le Chatelier's principle. In action, you disturb a system and the system shifts to counteract you. And what about the ice cream bucket? Why does it get asterisk colder? Level, thermal camera view of an ice cube. As salt is added, the color shifts from blue to deep purple-black. If salt were adding energy to melt the ice, the temperature should go up, but it drops. This is because breaking those molecular bonds in the ice costs energy. It's asterisk endothermic. Asterisk endothermic. When melting is winning, the system is frantically ripping bonds apart. It needs energy to do that, so it sucks heat out of everything nearby, the air, the bucket, and your delicious vanilla cream. The salt creates a runaway melting process that turns the ice into a heat-hungry sponge. In hashed philosophical pivot, the beauty of the truce, we tend to view the world as a collection of things. We see a block of ice as a collection of things. We see a block of ice as a thing that is either solid or liquid. But physics tells us that nothing is ever just one thing. Everything you see, the chair you're sitting on, the air in your lungs, the stars in the sky, is a temporary truce in a much larger war. Complexity and life itself are just states of asterisk dynamic equilibrium. Your body is constantly falling apart at the molecular level. You are only alive because your biological construction crew is working slightly faster than the demolition crew of entropy. Fast-paced montage of stars, burning cells dividing, and ice melting. It slows down to a single drop of water falling from an icicle. There is something profoundly beautiful about that. We aren't static objects. We are a balanced motion. We are the one-in, one-out policy of the universe. The ice isn't just sitting there, it's trying to become the ocean, and the ocean is trying to become the ice. Salt just gives us a glimpse into that struggle. It pulls back the curtain on the quiet war that's always happening right under our noses. Conclusion. So the next time you see a salt truck driving down a snowy highway, or you're hand cranking a batch of ice cream on a summer evening, remember, you aren't watching a chemical reaction. You're watching a rigged game. You're watching the failure of a balance. The universe doesn't hide its secrets behind complicated math. The universe doesn't hide its secrets behind complicated math. It hides them behind assumptions so obvious that we forget to ask the right questions. Let me ask you this. Asterisk what other obvious facts in your life might just be a balanced war you haven't noticed yet. Let's talk about it in the comments. I'll be down there trying to maintain my own equilibrium. Visual, the Gemini logo fades in. Below it, a button. Would you like me to explain the physics of why your ice skates are actually slippery?